Everybody, look at Johnny. He forgot to remind me.
Carly said something.
Yes, Carly?
Nothing.
Oh,
What?
she insulted you.
What?
I never insult you.
You got a hairline.
Okay. Now, it does say that any motion can be done in 1 dimension, 2 dimensions, or 3 dimensions. We're going to stick with the easy stuff and do 1 dimension. So if I have a number line, and I go that direction, is that 1 dimension, 2 dimensions, or 3 dimensions? It's 1 dimension. Going that way is 1 dimension. Going that way is 1 dimension. Going that way is 1 dimension. That would be 2 dimensions. Your x is changing, your y is changing. 2 dimensions. Here, what's the only thing changing? Your y. Your x isn't changing, is it? Okay? So we're going to focus on 1-dimensional motion, because it's the easiest type. So, alright, so did the ant move?
Yes.
Because he had a displacement or a change in position over a time period. I wish they'd showed him flying off the screen now. Alright, distance. Thunder. Alright, so distance. What kind of quantity is distance? A scalar? Scalar quantity, yes. It's okay. She has the guts to actually speak up, which Pascal don't. Okay, scalar. What's scalar? That's magnitude, okay? So distance only tells us the magnitude, doesn't tell us what?
The
Direction, okay? Indicates how far an object has traveled during a time interval. Doesn't tell us anything about the direction that something is traveled. Now, what I want you to do is find a location. Probably the best location is the very back of your notebook or your notes. We're going to start building a table that has all of the variables that we're going to see in this chapter, and it's going to get lengthy. Okay? And you're going to need to reference this quite often when studying for tests. Okay? Distance is not our first variable that we've talked about. What was our first variable we talked about? Time. So the name is time. The variable is t, and the most common unit. Any ideas? Second. Abbreviated S. Okay? You need to look back on this quite often, because when we start getting into the math, if you don't know what the variables mean, can you do the math? No. You're not going to know where to put the numbers if you don't know what the variables mean. And sometimes they don't say the time is. They might say over a 14-second span. Well, how would you know what they're talking about if they don't tell you what that's exactly the word time? You're going to look at what? Yes, the unit. Okay? Next one that we're just doing here. Name, distance. What do you think the variable is? Any idea what the most common unit is?
Inches.
That's not going to be American. You're close. Meter. Yep. Yep.
So, displacement, would that be the same as distance or?
It's the vector quantity version of distance.
Because last year they had displacement equal
No, that's a different variable for displacement. It's change in x, which we'll get to, I think, today. Well, yeah, I think today. Now, you might want to make a side note, I don't know where, that this is scalar. It's not a vector quantity. Okay, time is, I don't know if I've ever heard it stated whether it was vector or scalar. I wouldn't write anything down for that. You could probably argue both. You could probably argue scalar because it doesn't really give you direction, but you could argue vector because you're going in the same direction through life. Okay? Displacement. Don't lose your spot because we're going back to your table after you write this in your notes. Don't touch that. You'll burn yourself. Don't touch that. No, I'm not making Pop-Tarts. Yes?
Are we going over velocity
I think we're going over speed today. I don't know if we're going over velocity. Yeah. Okay, so displacement. Here we see this word. Change. I should have maybe change in. What did I say represented change in?
Delta.
Delta. So we gotta add another variable here. It is actually change in x. Because we're doing one-dimensional motion, so we're usually going to be changing on the x-axis. And its most common unit, any idea? Blow your mind. What's the matter?
Mr. Merfield, vector thing.
So what
Where he
vector?
talks like. Oh, yeah, true.
Okay. Alright. So, now I'll explain really the main difference in the visual here in a sec. Distance is just how much distance you've traveled or how much your position has changed over the course of a time period. displacement is going to be your final position minus your initial position. So distance is your scalar version, displacement is your vector version. So your displacement will have your direction. Now, let's continue on here. Oops. I realize that my little chart up there kind of is disproportional. Sorry. Okay. You're going to see a lot of relationships between scalar and vector. Right? Distance is to displacement as speed is to velocity, which is what we're going to get to as we progress. So let me try to give you an analogy here of what this looks like. So you're in your kitchen, in your living room, in your house. Okay? You start on your couch and you go to that chair. Is your distance and your displacement magnitude going to be the same? In this case, yes. What? Okay, so distance is how far my total travel, right? This is my total travel in the case of this, just here to here, whatever that distance is my distance. Okay, let's say, wouldn't my final minus initial give me the same number? Okay, the only thing that would be different is I would have to put a direction on displacement. Now let me show you when they're not exactly the same. You go in, you get some water, you know, go around there, and just kind of wandering around. There's really no reason to want to get something to eat, and then you go back. Traveled a lot of distance, didn't I? What's my displacement?
Just from couch to chair.
Oopsies. My displacement is final minus initial. Where's my final location?
Chair. Minus cap.
So my displacement is that. My distance is my total distance traveled. My displacement is the difference between where I began and where I ended. Okay, isn't the outcome the same? It is. Okay, this is important. Let's talk speed. Golly, we're just adding variables like crazy in here. All right, speed. Symbol S. Yep. Yes, the most common unit is a meter per second, or a m/s. And this is a scalar quantity. What do Americans use? Miles per hour. We're not going to use miles per hour very often. Sometimes we will, but not always. Okay? Let's find speed. Okay, so it says, anybody know what rate means? What does rate mean? How fast? Okay, so speed is how fast you change positions. That makes sense, right? So if I change positions at 20 meters per second versus 40 meters per second, the 40 meters per second means I covered more distance or displacement or position in a smaller time interval. Okay? Now, here's your equation. Your equation is really just S equals D over change in T. If you take out those words, that's what your equation is going to be. This is our first, well, not our first equation. Technically, we had a change in time equation. Okay, this is our first legit one. Okay, that we're going to use today. Got your calculators on yet?
I'll do my locker.
Okay.
I'm prepared.
This is physics. You'll need your calculators most days. Pulling it out. Handy dandy right there. Creepers. How much power. Questions so far? Not throwing a lot at you. I threw at you distance, I threw at you displacement, now we're throwing in speed. We've got all these variables, it's going crazy. You alright? No, is that what you said? Okay. I'm gonna get rid of this. This is a cheap way of doing it. Alright, let's do this problem. Write this down. This one's an easy one, we'll get to more difficult ones. I want to be your Algebra 1 teacher for a minute here. Please teach Algebra 1. I bet you do. Okay. Normally I'm not going to give you ones that you can do in your head. This one you probably could do in your head. But I want to explain how I want you to do these problems because we're going to start getting to more difficult equations. We're going to start dealing with equations that deal with gravity and how fast it takes an object to fall from a certain distance. Or we're going to be able to figure out how high the object was if we know the time frame from which the object fell. We can figure out a whole bunch of things that are going to get more confusing. So I want to build a foundation that is very important here. So here is what you need to do. Listen carefully. before you do any math, you must, and I want you to do this on a quiz or a test, I will not be happy if you don't, you must identify and write down your variables. Okay, and we said these are our variables. So we're going to read the question, and we're going to identify the variables and write them down. It says if a motorcycle travels 540 kilometers, did it say the distance traveled was? No, it didn't, did it? Okay? Now you probably can figure this out from the context of the problem, but something that helps, now I know this isn't your most common unit for distance, but it's just a distance unit with a prefix on it. What's the prefix? Kilo. So, this is what I want you to do. I want you to put your variable and what it equals. And here's why this is important. You're probably thinking, Mr. Kramer, we don't really need to do this. This is an easy problem. We can do this in our head. Yes, right now. But wait till we have 10 equations in one chapter. The best way, listen to the words that are coming out of my mouth right now. The best way to figure out which equation you're supposed to use is by looking at the variables that you've been given. Does that make sense? Let the variables tell you what equation to use. Okay? Now, we know we only have one equation so far, and we know which one it's going to be. But just wait, we'll get more equations. Okay? And then it says in 2 hours. Does it say the time is? No. So you have to identify what variable it is by the unit. Now, I know it's not the most common unit, but it is a similar thing to the most common unit. So what variable are we talking about here? T. 2 hours. I know I'm being over dramatic on this, but we need to lay a really important foundation here so that we can progress when it become more difficult. And then what are we solving for? So I would just do S equals question mark. That's how you set up. Now if you look, you would look at your list of equations that you eventually are going to have, and you're going to say, okay, which equation has S, T, and D in it? Oh, the speed one. Now, you guys know that we're doing that because it's the only equation we have, but when you have more, do you see how you can identify which equation to use if you write down the labels? Are you seeing big picture here? Okay. S equals D over T, and it is the change in T, but it gave us the change here. Now, could it have given you an initial time period and a final time period, and actually you had to find final minus initial? It may do that. Okay, now you're just plugging in and solving. Thankfully, they just gave us one where we don't have to do any manipulation. You probably did this in your head. What's the answer? 270? 270 frogs?
First hour.
Nope. I know typically our speed is in meters per second, but we can have different units. Is a meter still a distance or position unit?
Yeah.
So is a kilometer still a distance and position unit? Yes. And I know we're not using seconds, but is an hour a time unit? Yes. Okay? Now notice, I have my units here, and they don't cancel each other out, so it's a kilometer per hour. The slash means per or divided by hours. So when you see 20 mph, what that is really saying is 20 miles per every hour. I don't know if you guys knew that. You guys know that? Okay. Do one a little bit more difficult. Ooh, you guys can't probably see that very well, huh? Is white better? Maybe this one might be. Alright, there you go. here's what I want you to do. Before you try to solve, I want you to first get in the habit of writing down your variables. So very first thing, write this equation in your notes and then start identifying what each variable is on the side. Okay, does it say the word speed, the word distance, or the word time up here? Does it say any of those words? Okay. Now, it's fairly easy to know what variables we're talking about now because we've only dealt with 4 variables that we've even given you. I haven't given you acceleration, I haven't given you force, I haven't given you momentum, I haven't given you gravity, I haven't given you any other of those other variables. Okay? So do yourself a favor. Learn them now. Okay? So if we were to label this now, it says you travel at, okay, unit alert, speed unit. S equals 25 meters per second. Over, didn't tell us, but unit alert, time is 5.7 seconds. How far? What does far sound like? All right. Still same equation, but solving for a different variable. Okay? Let's plug in. S is going to be replaced with what S equals, 25 meters per second. V over our time gets replaced with 5.7 seconds. Now we need to solve. It isn't solved for us. Okay, quick little crash course in Algebra 1 here. There are 2 things you need to solve a variable. I want to write this down somewhere. You guys probably know most of this. But 2 things you have to do to solve for a variable. First thing is you need to get the variable by itself. Do you know what I mean when I say that? I mean it's by itself on one side of the equal sign. It has to be by itself. Second thing that has to be true. The variable must be on top of a fraction. Because here's what a lot of time happens, is I'm solving for t, and everyone's like, oh, I just kind of moved the d. And then miraculously, the t comes from below to above. This is what I see kids do all the time. They go, oh, you just divide by d, and that equals t. Well, how did t get up from the bottom of the fraction to the top of the fraction? Right? Because if you don't put any fraction here, what are you assuming? Did you see what just happened? Okay? This happens a lot, is people get it, oh, it's by itself, so therefore I'm good. Well, no. It also has to be on top of a fraction. Otherwise, what you're solving for is the inverse of that variable. Okay? Anyways. Side note. So, gotta get it by itself. It already is on top of the fraction, so we don't have to worry about that. How do I gotta get rid of this? How do I get rid of it? Okay. Does everybody understand the idea of to get rid of something, you do the opposite? Okay? Because what undoes division? Multiplication. Okay? Does everyone understand why if you do it to one side, you do it to the other? Everybody understand that concept? What is this? It's an equal. So if you manipulate one side, you have to do the exact same thing to the other side, otherwise is it equal anymore? No. So your d, and I'll rewrite it in a way that proceeds left to right, would be 25 meters per second times, because that's what I'm doing over here, correct? Everyone following? 5.7 seconds. Take and plug in your calculator. My 5s and X's look very similar. Can I get a number? 142? Now, let me show you units here. This is something that you're going to need to get good at too. Your units cancel out. I have a second on bottom of the fraction, and I'm multiplying it by a second on top of the fraction. So your seconds cancel, and your unit is a meter. Does that make sense from a distance unit standpoint? Right? Here's another hint. If all your variables are in their most common unit, your answer variable will be in its most common unit. Prende? Okay. Blessed hump day, guys.